Hi there, this is Jacob Nash Algebra Lessons, and this is Unit 7, Lesson 7, on graphing and identifying logarithmic functions. So, we know exponential functions. We've known how to graph those. We already learned that earlier in this unit. This is the opposite. Remember, this is an inverse function of exponential. So, everything that we said for this lesson, which was, what was it? No, it was this one. Lesson 4, it's opposite for this lesson, Lesson 7. So, the parent function, now I kind of said that the parent function was this in the last lesson, but you can pretty much just substitute in a 2, because obviously you can't type in b into a calculator. So our just default thing is 2. Once again, it can't be 1, because if it was, then we will see in the next lesson that that would mean that it's just y equals x line. So that's why it has to be 2. And if you want to graph this in a graphing calculator, you'll notice that you can't graph this like this. You instead have to type it in as this. And that's what we learned in the last lesson, and we'll review more in the next lesson. So that's what we have so far. The base, which is 2 in this case, can be represented with b and can be any other number. So keep that in mind. You can change. It doesn't have to only be 2. It could be something else. And we'll learn about transformations in the next lesson. I didn't mean to say that about that. We'll review. We'll have logarithm rules in lesson 9. That's not the next one. I didn't mean to say that. So I messed up on lesson 4, and I said that exponential functions have a vertical asymptote. They have a horizontal asymptote. That was not a good thing to mess up on, because this is what has a vertical asymptote. They're opposites, so that's one thing to know. Oh, wait a second. I copied and pasted this. As you can see, it still says exponential. That's supposed to say logarithm, sorry. Loga, I'll just say that. Well, it's usually abbreviated as log. I'll just say that. Sorry, forgot to change that. It has a vertical asymptote of x equals 0. So we had for the exponential, we had a horizontal asymptote of y equals 0. But because this is the inverse, it has a vertical asymptote of x equals 0. Now you might think vertical x, I thought vertical was y. Well, if we draw a line at x equals 0, it is on the y-axis. That's why it's vertical. But it is at where x values equal 0. So that's why it's called that. Remember, for the parent function of exponential functions, we had always a y-intercept of 0, 1. But instead, we have an x-intercept of 1, 0. And there is no y-intercept because of the asymptote. Just like how there is no x-intercept for exponential functions. So you can see how that is. Then we have a table of values. Look at this table of values, and you can see that they are complete opposites of each other, that we have the x and y values switched. The operation, though, instead, we do the logarithm with a base of 2 to that. Now, I have this asterisk. To solve in the calculator, you cannot solve like that, because when you're asked to find, let's say, if x is 5, what is y for this parent function? The ideal function that we're going to do, if we're trying to figure out what y would be if x is 5, would be this. But in the calculator, you have to type it in as this, because the calculators cannot understand that. So that's what you have to do. That's the difference. So keep that in mind. And these are the basic values we get. As we can see, we do have our x-intercept of 1, 0. Okay. So, as I've been saying, notice anything different? It's the reverse. And it has a reflection over the y equals x line. So look, I have both things graphed here. So the opposites are the points shown. So we have a y-intercept and an x-intercepts that are opposite for both functions. And the asymptotes are horizontal and vertical that are opposite. So we can see the red is our exponential function that we already have talked about in this unit, and this is the logarithm. And we can see that they do look the same. And if you were to fold this along the y equals x line, which is pretty much right here, imagine folding this piece of paper in half, they would land on each other. So that's what we're trying to get at here. So that is how you can graph and identify logarithmic functions. Now, this isn't necessarily, I didn't say all that much about how to graph it, mostly just to identify it. We'll really be looking at graphing it in the next one on transformations. So that'll be it for this video. Thanks for watching, and I'll see you on the next one.